I'll record. So the way this works, this wants you to find the limiting reactant. You got 90 grams of sodium. You want to convert it to moles. You're going to convert 80 grams of H2O to moles. Now remember, the goal is to see which one of these is going to run out first, because in the limiting reactant, the thing that runs out first stops the reaction, so you have to use that for your calculation. So anyway, you do this for both of them. And if you haven't done this part yet, you should be writing this down, definitely. Alright, so 1 mole. Now these again are from the periodic table. Hopefully you know that now. So you do this part. 90, that gives you so you do this, and you're like, all right, you got moles of Na now, moles of H2O. Remember, the next step, though, in finding the limiting reactant, we have to account for the coefficients in the chemical equation. I'm recording. Now, remember, the next step is accounting for coefficients. They both have a 2. So, we should divide both by 2. It doesn't really matter at that point. And just if you want to make sure you understand, that's from the coefficient. Now, the thing is, though, since it's the same coefficient, it doesn't matter. Which one of these is smaller? Which one's smaller, 3.91 or 4.4? 3.91. That's the limiting reactant. So, I mean, if you want to divide by 2 again, it's still going to be the one that's smaller. It'll still be the same. Yeah, what?
So if Na was like 4, we divided 3.91 by 4?
Yeah, if there was a coefficient of 4. What? Where'd I get what? Okay.
So they had to be the same in
No, it's just whatever. Like, since that's a 2, we put a 2 there. Since that's a 2, you put a 2. That's all it is. If this one was like a 5, you'd be writing a 5 there for sodium. Like, it doesn't matter. You know what I mean? Just whatever it is, you just do it. But this is a good example because, in this case, you see how you have 90 grams and this is 80? Well, in this case, the bigger gram amount actually turned out to be the limiting reactant, didn't it? So this is why you can't just simply look at it and be like, oh, this one's smaller, that's it. So once you get to here, then you realize, okay, sodium is the limiting reactant. That's great. Because there's less of it. There's fewer moles, that's why. So you then simply take sodium now, and you actually do what it says, which is to calculate how many cubic decimeters of hydrogen there are at STP. So you just plug your stuff in, and you are going to do a grams to moles conversion now. Grams to moles to volume. So we are going to convert now from the mass of our limiting reactant to moles to volume. So mass to moles to volume. All right, that's the goal. Now, the way we actually do it, you just set it up the same as always, except you start now with your limiting reactant. If you did this with water, it would be wrong because you would actually end up with more than you should. So you do grams to moles. Notice this is exactly the same as this step. So if you had wanted to just start at moles of sodium, which you already had calculated, you could do that, but you don't have to. So moles of sodium. Now the problem wanted us to convert to cubic decimeters of hydrogen. So in this case, that's hydrogen, H2, so moles of H2. Now these are the coefficients, so H2 has what for a coefficient? 1, sodium has 2. So just so you know, that's coefficients, atomic mass, just telling you where everything's coming from. And then your final step, moles of H2, and it wants us to convert to cubic decimeters, remember? So we're actually going to do cubic decimeters of H2. Now, I know that's a conversion we don't use as much, so it's good to actually take a look at. So moles to volume, you're going to multiply by 22.4, the molar volume constant at STP. So 22.4. So then we'll say, you know, this. No, that's if you had cubic centimeters, but we have cubic decimeters.
We're gonna have the charts.
No. So you do this, you'll get your answer, whatever it might be. So, I don't know what it is. Just figure it out. So you do 90 times 22.4 divided by 22.99 divided by 2. And you get 43.85 cubic decimeters of H2. So that's great. Make sure your units cancel out. So that's 1.
That's 1A.
So you do not,
Divide by 22.9.
because it's on the bottom, so you divide. Remember, if it's on the bottom, you
Why'd you do it? Divided by 2. Then you multiply, and then divided by
doesn't matter. The math works out the same. Remember how it works, the order of operations. You can do that. So that's number 1. Now, number 2 is where a lot of you were like, listen to this, because I know a lot of you were like, I don't know what's going on with number 2. So once you get this thing with number 1, number 2 says, which reactant is in excess and how much is left over? So, all right, so to begin with, so this is number 2, SP56. So to begin with, which reactant first did we say was the limiting reactant? Sodium was limiting. So that means, by default, what is the excess reactant then? So H2O is excess, just so you know. So that means that for this, to answer that, I mean, that's pretty simple. H2O is excess. But it also says how much is left over. So what it's saying is this. You have 80 grams of H2O. Okay, a certain amount of that is going to be used up. So some of this will be used up. And then, you know, after the reaction, so after, there will be less, obviously. They want you to figure out how much is left here. Like how much has not been used up. So the way you're going to do this, if a problem asks you to do this, and I'm trying to remember, there might be one like this on your test actually, so you probably want to pay attention. If the problem asks you to do this, you again still start with the limiting reactant. So you still start with the limiting reactant. And then what you do is simply convert from the limiting reactant to the excess reactant. So we are going to go from sodium to H2O. Grams of sodium to grams of H2O. Then we'll subtract our answer from 80. All right? So you will do 90 grams of sodium. Grams of Na. Moles of Na. Moles of Na. Our new thing is going to be moles of H2O. And then we'll just keep going with units, and then I'll plug everything in. So all this is a mass-to-mass problem from mass of sodium all the way to mass of water. That's all we're doing there. Now the numbers, that 1 mole is equal to 22.99 grams. You need to know your coefficients here for H2O and sodium. In this case, it's actually a 1-to-1 ratio, 2-to-2. It's the same thing as 1-to-1, but we'll put it in like that. And then finally, the molar mass of water is 18.02, and that's 1 mole. So you do this. This is going to tell you how much H2O is used. Just so you know, what we're calculating at this very minute is how much is used, and then we'll figure out how much is left over. So 70.54 is used up. So yeah, so now, to find how much is left, you would do 80 grams minus 70.54 grams, and this will tell you how much H2O is left. So that's how you do those problems. That's exactly how you do number 4 and number 6 on here as well, just so you know. That's it for this page. I want to do it. If I do this reaction with 15 grams of sodium sulfate and get a 65% yield, how many grams of sodium phosphate will I make? All right, so this is a percent yield calculation question again. The first part, though, is simply mass to mass. The only new thing, again, is doing the percent yield at the end. So it says if I do this reaction with 15 grams of sodium sulfate, so it's saying you have 15 grams right there. It wants to know how many grams of sodium phosphate will you make. All right. Now, the first step in doing all this is calculating the theoretical value. So the first part of this, remember, our formula for doing this is that, we're going to do actual yield, which is what we really got, divided by the theoretical times 100. That will tell us our percent yield. So what this is telling us, though, right now, is that we got 65%. Like, they're telling us our yield was 65% here. You should listen. This is definitely like a test question, people. I know, I see half of you not paying attention. So, if our yield is about 65%, they're not telling us. We have to say, what was the actual yield? We are actually trying to figure this out. What is this? Now, we have no way of determining this with our calculation, but we can calculate the theoretical yield. We can do a mass-to-mass problem of, sodium sulfate to mass of sodium phosphate and figure out what goes in theoretical yield. Then, using some simple algebra, we can figure out our actual yield. Okay, that's what this problem wants us to do. I hope I've diagrammed it out pretty well for you. So, what you will do, you simply do a mass-to-mass problem right now. You're going to go grams of Na2SO4 to grams of Na3PO4. So mass to mass, those two things. So you do 15 grams. Whole deal. So 1 mole of that. I feel like I already have it calculated somewhere. So 1 mole of that will be equal to, no, I don't, let's figure it out. So you do 22.99 times 2 plus 30.97 plus 16 times 4. So that gives you sodium sulfate's mass. So this is again from the periodic table. Now we will convert moles of sodium sulfate to moles of Na3PO4. This is coefficients again, so our coefficient for sodium phosphate is a 2, sodium sulfate is a 3, taken directly from our equation. Final step, convert to mass. Many people told me I used the wrong mass. I wasn't even paying attention. Thank you. It's not 140.95.
Yeah, you hit extra numbers on your calculator.
No, what I did was I used the mass for phosphorus instead of sulfur. See, 30.97 is phosphorus, not sulfur. So plus 32.07 plus. Wow, that made a big difference. That's better. Now, you get to that point, and your final step is to do grams of Na3PO4. So that'll be 22.99 because of sodium's mass times 3 plus 30.97 plus 16 times 4. So all right. So you do all this, you get your answer. Speak. No, go ahead.
I thought that I didn't answer for it. I don't feel for like safety.
Nope.
You still belongs to you. Test can be like
The test is like 16 questions or something. You got.
stuff in the beginning, like
Think about it. The stuff from the beginning is what was is like it's all part of this. Like you're doing a mole. You're doing a mole conversion right now. You know what I mean?
is it gonna be simple?
Maybe like 2 or 3. I mean, it's to be honest, there's not that much simple stuff on it, but you know, why would there be? That wouldn't be any fun. So your theoretical yield should be 11.54.
All that.
Yep, pretty much. So this is your theoretical yield. So now you take it and you plug it in here. You solve for your actual yield then, okay? So that's what you do. So we are solving for our actual yield. We have now calculated that our theoretical yield is 11.54. We know we are multiplying by 100. That will equal 65%. A simple suggestion that I would have for you is to not write it like this, actually. You know that 65% is what in decimal form?
0.65.
0.65. So what I would do is actually rewrite it. I would not have written it like this at all, just to show you. I would have rewritten as actual yield over 11.54 is simply equal to 0.65. You know, all I did was convert that from percentage to decimal. Now it's a pretty darn easy problem to solve, isn't it? So you multiply both sides by 11.54, and you find that your actual yield is what? Oh, I have to do it? Okay. 7.5.
Where's your 0.65?
The problem. So what I did, this final step was simply converting 65% to decimal form. So instead of just, and like, because all it does, we can get rid of that 100 then. Like, I'm just simplifying the problem for you, because then you would have had to divide by 100 and then multiply. So I just like took that step out. Now, once you get this, there's no need to like multiply by 100. There's no percentages necessary, because remember, they gave you the percentage. They said in the problem, remember, that you have a 65% yield. They simply wanted to know, okay, what does that make our actual yield? And that's what we figured out right there at the bottom. So, I mean, that's about as complicated as a percent yield question can get. Just so you know, I think that is actually there's one on the test pretty much exactly like this, I think. So just be aware of that.